Welcome to IOQM 2022 paper part 3. So in this one we will check questions from 18 to 22, all 5 marks questions. Let's continue. Yeah, first question is let m comma n be the natural numbers such that m plus 3n minus 5 equal to 2 times LCM of m comma n minus 11 times GCD of m comma n. Find the maximum possible value of m plus n. Okay. So let GCD be G. Let's call GCD of m comma n as G. Then m is Gx and n is Gy, where x comma y are relatively prime. And LCD of m comma n will be Gxy. Okay. So once you know this, m plus 3n minus 5 equal to whatever is given equation, you replace with these values. What you will get is Gx plus 3Gy minus 5 equal to 2Gxy minus 11G. Okay. Simplifying, what you will get is G times x plus 3y minus 2xy plus 11 equal to 5. Okay. So if you clearly see, this is the integer, 5 is a prime. So obviously, G has only two possible values, either 1 or 5. Okay. So let's take case 1. Case 1, G equal to 1. If G equal to 1, 3 plus x plus 3y minus 2xy plus 11 has to be 5. Then based on that x value, we can derive x equal to 3y plus 6y 2y minus 1. Okay. Now m plus n equal to gx plus gy, that is g is 1, so x plus y, and x is, you take value from here, plus y. Simplifying, what you will get is m plus n is 2 times y square plus y plus 3 by 2y minus 1. Okay. For case 2, g equal to 5, so the given expression, the x plus 3y minus 2xy plus 11, that is this expression, has to be 1. So in that case, x equal to 3y plus 10 by 2y minus 1. Once you know that m plus n equal to gx plus gy, which is 5x plus 5y, because g is 5. Okay, what you will get is m plus n is 10 times y square plus y plus 5 by 2y minus 1. Since y's are positive, obviously out of these two cases, this is maximum. Okay, so trying to find maximum possible value of m plus n. Correct. So this is maximum. So let's take that value. Okay, max m plus n equal to this one, 10 times y square plus y plus 5 by 2y minus 1. Okay, 5 for y equal to 1. Max of m plus 1 is nothing but around 70. For y equal to 2, the value is 36. For y equal to 3, the value is 34. If you see, it's clearly as y is increasing, the max m plus n is reducing. Okay. So we don't need to calculate further. The max value is 70 here. Okay. So hence m plus n maximum is at y equal to 7, y equal to 1. So that is max m plus n is 70. Okay. So this is medium, a little bit you need to understand and observation. Okay. Next, consider a string n1. Okay, there are n1s. We wish to place some plus signs between the ones so that the sum is 1000. Okay. For instance, n equal to 190, we may put plus sign so as to get 1190 times and 1 10 times. Okay, so 11 into 90, that is 990 plus 10, which is 1000. If a is the sum of positive integers n, for which it is possible to place plus sign so as to get the sum 1000, find the sum of digits of a. Okay. So the question is, if there are a number of ways you can place these ones, okay, and plus signs to get 1000, okay, then what is a? And exactly what they are asking is sum of digits of a. Okay, let's see. Okay, so first let's start with the least possible ones. What is the least possible one possible? Least possible ones are possible. That is 9 sets of 111 and one set of 1. Okay, 9 into 111 is, so if I add 111 plus 111 plus 111 plus 9 times and then plus 1. Okay, that is 9 into 111, that is 999 plus 1000. Okay, so how many ones are there in this expression? 9 into 3 plus 1, last one, which is 27 plus 1, 28. Okay. Let this be n1. Okay. Now, next what I will do is, I will convert one of this 111 into 11. Sum of 11s and 1s. Okay. How many I can convert? 11 into 10, that is 110 plus 1, right? 111. So I can convert 111 into 11 plus 11 plus 11, 10 times plus 1. Okay. So how many extra 1 digits I am adding? Okay. Two 1 digits here. 2 into 10, that is 20 plus 1, 21, minus this 111 will vanish. So minus 3. So 18 extra 1 digits, which means my N2 is 28 plus 18, that is 46. Okay. Now I will continue to convert each 11, 111 into, next is each 11 I want to convert into ones. Okay. So this will take 11, basically 11 ones, right? So that is 11 into 1, 11. Okay. So 11 extra ones I will get. So, and 2 will vanish, 11 will vanish. So 11 minus 2, that is 9. This is step size. So from now onwards, every conversion of 11, I will get 9 extra ones. Okay, up to until I finally get 1 plus 1 plus 1 1000 times, which is 1000 ones, right? So if I summarize what we just now did is 46 to 1000 in AP in step of 9, correct? First is 28, then second is 46, but this is all after this. Every number is in arithmetic progression with a difference of 9, okay, from 46 to 1000. So this I can find out how many n's are here. I can find out easily. Okay. So the final term is a plus n minus 1 into d. So in this case, 1000 equal to 46. That is beginning is 46 plus n minus 1 into 9. So I will get n as 107, and then this is 1 remaining. So total is 108. So A equal to count of this one. How many are there? That is 108. Right? So the answer is 1 plus 0 plus 8, that is 9. This is a bit hard. Okay, next. The problem states that for an integer n greater than 3 and a permutation of k equal to p1 to pn of 1 to n. So basically, there is a set from 1 to n. Okay, n is greater than or equal to 3. Okay, we say that p1 is a landmark. Okay, p1 is a landmark. Okay, with the given condition. Okay, what is this condition? Previous number minus PL, okay, into PL plus 1, that is next number minus PL should be greater than or equal to 0, which means PL should be either less than the neighboring numbers or greater than neighboring numbers. Okay, only then it is called a landmark point. Okay, for example, n equal to 7, if you take the permutation, okay, there are 4 landmark points. That is 7. 7 is a landmark because it is 2 and 6 are less than it. 6 is a landmark. No, 7 is greater. 4 is less. So no. Okay, 4 is a landmark because 6 and 5 both are higher. Okay. Then 5 is a landmark because 4 and 1 are less than it. 1 is a landmark because 5 and 3 are greater than it. Okay. So now you understood what is landmark point. Now, for n is greater than or equal to 3, Ln denotes the number of permutations of 1 to n, which exactly have only one landmark point. Okay. So we need to find out which permutations have only one landmark point. Okay. Now we find that such number of permutations which have one landmark point, and then find a n where Ln is a perfect square. Okay. Let's see how to do. So first let us understand the problem once again with the example. 5 numbers will take 1 to 5. So we can arrange them in this order, right? 1, 2, 3, 4, 5, 1, 3, 2, 4, 5, 1, 5, 2, 3, 4. Okay. Now in each permutation, the digits in second, third, and fourth are called landmark points. Okay. 1 and 5 are not landmark points because they don't have two neighboring numbers. Okay? First and last, basically. Now, here 2, 3, 4 are landmark points because 2 minus 1 is 1 minus 2 is negative and 2 minus 3 is negative. Okay, so both are same. So 2 is a landmark point, 3 is a landmark point, 4 is a landmark point because it's in increasing order. Okay. Now, okay. So previous landmark number minus post landmark number. Okay, this should be greater than 0. Okay. So this has no landmark points. Okay, 2, 3, 4 are eligible, but they are not because one is less, other one is more. Okay. So if you have continuous sequence, that means you don't have any landmark point. 1, 3, 2, 4, 5, 3 and 2 are landmark points. Okay. If you take 3, 1 and 2 are less. If you take 2, 3 and 4 are more. Rest all don't qualify. But if you take 1, 5, 2, 3, 4, okay, 1, 5, 2, 3, 4, if you take, uh, you have 5 as the landmark point. Only total number of permutations where only one landmark point is possible, that is L of n. Okay. So we need to calculate that how many one landmark point permutations are possible. Okay. So now let's go into the problem. So if you take the example of same example, we know that only the 5, 1, 5, 2, 3, 4, that is this one has one landmark point. Okay. So if you observe carefully, the point landmark point is possible with only highest number and the lowest number in any permutation. Okay. Rest all should be in the sequential order, ascending or descending order basically. Okay. Ascending order in this case. Okay. Why it is like this? Any other combination you take, you will have multiple landmark points. Okay. Any other permutation you take, you will have multiple because 5 is biggest number. So you keep it anywhere in the sequence. Okay. The neighboring will be less than uh, uh, the highest number. Okay. So it is a landmark point and rest all should be in a sequential order. That means you will not find any other landmark point. Same way, you take the lowest number, okay, that is the first number, you keep it anywhere in between, okay, it will be less than the neighboring numbers, which means it will have a only one landmark point. Okay, so these are the only permutations possible. Any other change, you will have multiple landmark points. Okay, now let's see. Okay, hence let us do a number of possible permutations with n numbers. Okay, if you take 1 to n, basically, if n is in second position, okay, n is in second spot, you have how many combinations? The first number can be any number because any other number is smaller than it, right? So you have n minus 1 number, so n minus 1 C1 possibilities for the first part. Rest anyway will be in increasing order, sorry. Okay, rest all will be in the increasing order. Okay, because you are taking the highest number, they all should be in the increasing order. Okay. So there are n minus 1 C1 possibilities. Okay, you understood this point? Okay, now let us make a table actually. So if n is in second position, we have n minus 1 C1 possibilities. Okay, if n is in third position basically, then first two spaces can be filled with any two numbers, but in the only one order, right? Increasing order. So that is n minus 1 C2. Rest all will be again in the increasing order. So similarly, we have 4, then up to n minus 1. N minus 1 will be how many combinations possible? N minus 1 C, n minus 2. These many combinations are possible. This is only with highest number I took. And same table you can make for lowest number also. Exactly same number. So total number of combinations are 2 times n minus 1 C1 plus n minus 1 C2 plus up to n minus 1 C, n minus 2. Okay. Now, this is nothing but 2 to the power of n minus 1 minus, okay, what are the two terms missing? If you see this one, n minus 1 C1 to n minus 1 C n minus 2, right? The missing numbers are n minus 1 C0, the first number, Last number is n minus 1 c n minus 1. Okay. If all of them are summed up, then it is equal to 2 to the power of n minus 1. So the missing numbers I am writing here. Minus n minus 1 c0 plus n minus 1 c n minus 1, which is equal to 2 into 2 to the power of n minus 1 minus 2. Okay. Hope you understood this. So this is what ln. We just need to find out from this expression 2 into 2 to the power of n minus 1 minus 2, which one is the perfect square for a given n. Okay. So just note down the formula here for the combination sum. Okay. So third part of the question, now we need to find the perfect square. 2 into 2 to the power of n minus 1 minus 2 equal to p square. Okay. Now I am taking 2 out. So 2 square into 2 to the power of n minus 2 minus 1 equal to p square. Correct. So from observation, I can easily tell n equal to 3. If you take n equal to 3, basically, because here it is 2 square, p square. If I want to equate it, this should be 1, right? This is 1 only if this is 2. 2 minus 1 is 1. So this is 2 only if n is 3. So n equal to 3, p square equal to 2 square. Hence 3 is one solution possible. Let's find out other solutions. Okay, for n greater than or equal to 4. Okay. If you take the second term, 2 to the power of n minus 2 minus 1 is an odd number. Correct? This is a odd number. Okay, which means it is in the form of 2x plus 1 whole square. Okay. So 2 to the power of n minus 2 equal to 4x square plus 4x plus 1, which implies 2 to the power of n minus 2 equal to 4x square plus 4x plus 2, which is equal to 2 into 2x square plus 2x plus 1. Okay. Okay. So 2 to the power of n minus 3, because the 2, 2 and I am cancelling actually both sides, equal to 2x square plus 2x plus 1. Okay. Now if you see, for n is greater than or equal to 3, okay, n is greater than or equal to 3, 4, sorry, n is greater than or equal to 4, you will not get a value which is equal to LHS equal to RHS, because for n is greater than or equal to 4, this is always a 2 to the power of n number, right? That is even. And this side, this is even number plus even number, which is even plus 1, odd number. So it is odd parity, right? So for n greater than or equal to 4, you will not find any other solution which satisfies that equation. Okay? Because they are all different parity. Okay, so only possible solution is n equal to 3. Okay, so at n equal to 3, you will find a perfect square. Ln will be a perfect square. This is the only solution. I think this is very, very tough problem in IOQM. This is first level exam if you consider that way. This is really tough. Okay, yeah. Next, ant is at a vertex of a cube. Okay. Every 10 minutes, it moves an adjacent vertex along an edge. Okay, this is at A. Okay, every 10 minutes, it moves to the nearest vertex via the edge. Okay, if n is the number of 1 hour journeys that end at the starting vertex, okay, that means the ant starts from here and after 1 hour, every 10 minutes, it will move and after 1 hour, it will come back to A. Okay, find the sum of the squares of digits n. Okay, first you find out n, how many such journeys are possible, 1 hour journeys where it can come back, and then you find out the sum of squares of the digits n. Okay. So if it is 1 hour, then we know that every 10 minutes it makes one move, so which means it is 6 moves. Okay, so in 6 moves it should come back. Okay, now first we will take case one where it will go only one edge. Okay, so let's take it goes only via x-axis from A. Okay, x-axis it will just go and come back, go, come back 3 times, right? So 1, 2, 3, 4, 5, 6. It is back to A, correct? So how many ways it can make? There are 3 axes, x-axis, y-axis and z-axis, correct? So 3C1, right? So that's 3 ways it can go. Now let's take case 2 where it has 2 edges. 2 edges means it. Let's take two axes, that is x-axis and y-axis. So in this case, it can go xx, xx, yy. Okay. Okay. Only 2 axes we are considering, right? So this is how it can go. Okay. So how many ways it can go? This is simple combination. 6 factorial total, that is y, 4 factorial repetition of x, and 2 factorial repetition of y, which is equal to 15. Okay. Now if you consider y, x, okay, it can go this way also, right? 4 y's, 4 via 4 y-axis edges and 2 x-axis edges, right? So twice this number, that is 30. Okay. Now there are three axes, right? So it can choose either x-axis, y-axis, y-axis, z-axis, or z-axis, x-axis. So there are total such three times such 30 combinations are possible. Right? So total number of paths it can take is 90 for the case 2. Now let's see the case 3. Okay, it will go all three axes, three edges basically, x, y, z, z. There is no other combination possible. Okay, it cannot have one y and one z, then it cannot come back. Okay, so if it goes this one, then we know it is simple. 6 factorial by 2 factorial into 2 factorial into 2 factorial, which is 90. Okay, so total number of paths it can take is 3 plus 90 plus 90, that is 183. Now what he is asking is find the sum of squares of the digits n. Okay, so that is n equal to sum of squares of digits n equal to 1 square, that is 1, plus 8 square 64, 3 square 9, which is equal to sum is 74. This is the answer. Okay. So this is medium. Last question was very tough actually, but this looks medium at least. Next. So this is the last problem. Binary sequence is a sequence in which each term is equal to 0 or 1. So this we know. Binary sequence is called a friendly if each term is adjacent to at least one term that is equal to 1. Okay, so he is defining a friendly sequence. Okay, a friendly sequence is one where adjacent at least you will have one number 1. So at least one single digit 1 you will have. For example, sequence given here is friendly because 0 has one adjacent one, 1 has one adjacent one, this one has one adjacent one here, because this 0 has one adjacent one here, this 0 has one adjacent one here, this one has the adjacent one, this one has two adjacent ones, this one has one adjacent one. Okay, so this is what is defined as a friendly sequence. Okay, let f of n denotes number of friendly binary sequences with n terms. Okay, so if you take n binary digits, how many friendly sequences you can make combinations? Okay, that is denoted by f of n. Now you find the smallest positive integer n greater than or equal to 2 such that f of n is greater than or equal to 100. Means how many binary digits you require to make a friendly sequence. Okay, 100 friendly sequences with those binary digits. That is the question. So this is when I looked at this paper, this is probably the toughest question I have ever seen in IOQM. Okay, I hope I'll not see tougher questions than this at level 1 IOQM. Okay, so there are several people solve this problem in many ways, but the explanations are not satisfactory how they derived at the recurring equation. Okay, this is solved by recurring equations actually. You have to find something similar to Fibonacci. Okay, but how they derived at the recurring e- equation function is, I am not satisfied. It's not very clear for many of the explanations. Though they all derived at the same recurring function. Okay, so I have my explanation here, but if anybody can find a better explanation, please just put it in the comments. Okay, so f of 2 equal to 1. Okay, f of 2 is 1. What is that? Only sequence possible is 1 1. Okay, why not 1 0? Okay, for 1 0, 1 has 1 don't have a neighboring one. Correct, so 1 0 is not possible. Only 1 1 is possible. Okay, for two digits, if f of 2 that is. Okay, only one is the solution. Okay, Now, f of 3 if you take, there are three solutions possible. 111, 110, 011. I don't need to explain this. I need to explain why something is not possible, right? So you take 101. Why it is not possible? Because 0 has both neighboring ones, but none of the ones, okay, first one and last one don't have uh, a neighboring one, okay, because it is 101, okay. So these are the three possible. No other combination is possible, okay. Now, look at f of 4, okay. Now these are the four possible combinations. None of the other four are possible. You can take any four-digit binary number and you can try, like 011, 0 is possible. It is already there. But 1001, not possible. 1010, not possible. Um, Mainly, you look at actually the second and last but one. N minus 1 has to be 1. Okay. Otherwise, it's not possible. Okay. Second and n minus 1. These two has to be 1. Okay. Now, similarly, f of 5 equal to, these are the possible combinations. That is 5. Okay. So, I actually looked at, I wrote several binary sequences and observed very clearly. From this observation, I can tell the actual recurring equation is f of 6 equal to 9. Okay. So now these are the possible values. Okay. So f of n plus 1, I can define as f of n plus f of n minus 1 plus f of n minus 2. Okay. Let's take 9 here. Okay. 9 equal to, what I am trying to tell is 5 plus 3 plus 1, that is 9. Okay, correct? That is correct actually, right? 5 plus 3, 8 plus 1. Okay, so from my observation, I have written a solution actually, and this is the recurring function actually. Okay, it's kind of Fibonacci series. It is sum of three functions, three previous sum basically. Okay, so it is very difficult to uh, come to this function, basically a recurring function, mathematically, because I have seen explanations given in the internet, but none of them are really, they have some mistakes. Everybody has made some mistake, but they have finally observed this is the equation, correct equation. Okay. So nobody has basically derived this equation mathematically. I love to see if somebody can derive this equation. Okay, so this is from observation I made this equation. Okay, observation I wrote several to f of 10 I told. Okay, and then concluded that this is the correct Fibonacci, uh, correct recurring equation. Okay, so once you have this one, it's very simple problem. Okay, f of 1 is, of course, you have to take 0 because no combination possible, one digit. F of 2 1, f of 3 is, and then so on. Okay, so if you apply this function and write, then you know where you are getting more than 100, f of 11, correct? So that means smallest n possible n is 11, okay? So this is the answer for this one, okay? This is really a tough problem. Okay, so these are all the 5 marks questions. We'll have one more video for yeah, 10 marks questions, two 10 marks questions, okay? Thank you. This looks like this IOQM is really tough. Okay, most of the problems are very tough. You need to have complete understanding of number theory and geometry, trigonometry. I mean everything basically. Especially the analysis. Number theory is the most critical part. Okay, combinations and permutations. Okay, okay. Let's see. Let's see the next video with 10 marks questions. Thank you.